All right, so for our first example here, it says express log base b of m times n to the second power in terms of log base b of m and log base b of n. So we're just really working with that first property and the exponent property there, right? So another way of asking this question is to just expand this logarithmic expression. So when you do this, right, you're looking at your logarithmic expression here, where the argument is m times n squared here. You kind of want to basically use the properties of logarithms and reverse the order of operations within that argument, right? So order of operations in that argument are, first you would raise n to the second power and then multiply that by n, okay? We're going to reverse that process to help us expand it, right? So the last thing you would do in the argument is really the first part of the expansion you're going to do, right? So the last thing here would be the multiplication of m. So I'm going to then decompose this logarithm into two different logarithms of the same base, right? So this addition here is where that multiplication shows up. So first is log base b of m plus log base b of n squared here, right? That's the first part of the expansion. And then, you're not fully expanded at this point, right? So the log expression is fully expanded when the argument inside the original logarithm contains a single factor, right? So if you focus over here on the left, m is a single factor. It's not being multiplied, it's not being divided, and it has no exponents, right? But on the second term here, there's an n squared, so that has an exponent, so we have to continue to expand upon this, right? So we're going to use our power property here, and where we can take this exponent of 2 and bring it out in front of the logarithm here, right? So that's what we're going to do next. And at this point, we have the original log base b of m from up above, plus, and then now it's 2 times log base b of n. At this point, this would be considered fully expanded, okay? The argument in both of these log expressions contains no multiplications, no divisions, no fractions, no exponents. We're done. Now, some would argue that you could go further, and it's your choice whether you do this or not. This piece that we're looking at right now is fully expanded, but you could take this 2, right here, this 2, right? And you could rewrite this as the sum of 2 different logarithms, right? So 2 log base b of n could also be expressed as log base b of n plus log base b of n. So you could expand it one step further. Both of these are considered fully expanded. It's really your choice there, whatever you prefer to work with. Next example. Okay, a little bit more complex, and there's some other properties we have to include. So express log base b of square root m cubed divided by n in terms of log base b of m and log base b of n. That means log base b of m and log base b of n must be in your expansion. And another way to state this, instead of saying express, we could just say expand this logarithm. So the first thing you want to look at is, radicals cause problems. So this radical right here is also a fractional exponent, right? The square root is also an exponent of the 1/2 power. So first thing I'm going to do is just rewrite this log with a 1/2 exponent inside the argument here. And then there's a few different ways we can deal with this. But again, ultimately, we're working on the reverse order of operations. So if you look inside this logarithmic expression here, right, inside the argument, following the order of operations, the first thing you would do is you would raise m right here to the 3rd power, then you would divide it by the n, and you would raise it to the 1/2 power. So we reverse that order. So first thing I'm going to do is take 1/2 and push it out as a coefficient right here, right? So now I have 1/2 times log base b of m cubed divided by n, right? Again, reversing the order of operations. So here, order of operations say we would cube m first and then divide by n. So the last thing we did is divide by n. So that's the first thing we're going to do when we expand this grouping further. Key thing you have to pay attention to right now is that this red group right here is being multiplied by 1/2. So when we expand this red group into two logarithms from that quotient right there, we have to multiply that entire group by 1/2 still, right? So this quotient, fraction, division, however you want to view it, expands into log base b of m cubed minus, that's the fraction quotient division right there, log base b of n. This log term right here that's highlighted is fully expanded. It can't go any further. However, this first log term right here, log base b of m cubed, we have to take this exponent here, bring it out in front, right? And just be careful, this 3 is going in front of the logarithm, but inside that group there. Right, so this is where we're at now, right? So this is where the 3 shows up here. Now, inside this big group, that is actually not even close, inside this big group, right? So here and here, this big group here, this is technically considered fully expanded, but this group is also being multiplied by 1/2. So we're going to need to distribute 1/2 to both of these log terms here and here. So I'm going to make my distribution, and I get 1/2 times 3 log base b of m is 3/2 log base b of m, and then minus 1/2 log base b of n. That is your full expansion. It's, you don't need to go any further. Now, sometimes this expression may be written this way, 3 log base b of m over 2 minus log base b of n over 2, right? That division of 2 is the same as, that multiplication of 1/2 there. But this answer right here in the green box is perfect.